Okay, we're going to jump into 2.1/2.2, which is modeling expressions and creating equations. And we're going to start with some vocab terms here. So the first vocab word we've got is expression. It says a mathematical phrase that contains operations that could be like plus, minus, multiplication, or division, numbers, and or variables, but it does not have an equal sign, so no equal sign. So that part there is important. Okay, no equal sign. And then we've got an example over here, right? And they can look all sorts of different ways, but this is one example: 4x squared minus 3y plus 6xy minus 2. And then we look at the next vocab word, which is terms. And it says the parts of an expression being added or subtracted. So this is the different pieces of our expression. So in this expression here, we've got 1, 2, 3, 4 different terms. And then the next vocab word is coefficient, and that's the numerical factor of a term. So that's just the number in front of the variable. So in this case, we've got 4, -3, and 6. Those are the numbers in front of the variables. Those would be the coefficients. All right, let's start to model some scenarios using these expressions. It says, George is buying watermelons and pineapples to make fruit salad. He buys W watermelons. Okay, so they're using W here as the variable. W watermelons at $4.49 each, and P pineapples at $5 each. So in this case, P will be the variable for pineapples. Set up an expression that models the total costs for the watermelons and the pineapples. So we know that the watermelons are $4.49 each. So I'm going to do $4.49 W. And we know that the pineapples are $5 each. So that's going to be 5P. And it wants the total cost for all of these things. So I'm going to use addition because that would give me the total cost if I were to put those together, right? And I get my expression that models that. Okay. Next piece I wanted to look at was switching from a percent to a decimal, or a decimal to percent. And some of us have probably seen this before, but just a quick refresher on how to do this. If I'm going to go from a percentage to a decimal, to an equivalent decimal, then I can just divide that percent by 100, right? Or some of us may have seen that we can move the decimal point twice to the left. Okay, so like if I have, let's say, 50%, and I want to turn that into a decimal, well, I can just take my decimal point and I can move it 2 times, once, twice, to the left, and we'll end up with 0.5 as the decimal, right? And then if I'm going to go from a decimal to a percent, I can just do the opposite of that. Okay, so if I have some decimal, let's say 0.35, okay, I can either multiply it by 100 to get a percentage, or I can move the decimal twice to the right, once, twice, and we'd end up with 35%. So we'll go through a couple of these real quick. So if I've got 7% and I want to turn that into a decimal, okay, well, I can just go ahead and move that decimal twice to the left, or divide by 100, which would give me 0.07. 50% as a decimal we've already done is 0.50. 0.3%. So notice this is a percent, right? Even though it's got a decimal, so it's still a percent. So I'm still going to have to divide by 100 or move twice to the left. So I could go once and twice, which would give me 0.003 as my decimal. And we'll keep going here. 86% as a decimal would be 0.86. Okay, 0.3 as a percentage. Well, now I'm going to go twice to the right, so that would be 30%. And 75 twice to the right would give me 75%. Okay. All right, so that's going to lead us into the next part, which is solving percent word problems. It says the price of an item plus 6% sales tax of that item. All right, so we have to kind of think of this in a different way. If I asked you what 25% of 100 was, right? A lot of us would know this already. 25% of 100, right? A lot of us would know that 25% of 100 should give me should give me 25. Right, 25% of 100. So when I'm trying to figure that out mathematically, well, I can't just do, to figure that out, I can't just do 25 times 100 to get this answer, right? That won't work. What I actually have to do is 0.25 times 100, and that would give me that 25 that I'm looking for. So when I'm trying to find a percent of a total, percent of a number, I multiply by the decimal version of that percentage. Notice I took the 25%, I turned it into a decimal, right? So I took the 25%, I turned it into a decimal, and then I multiplied it by 100, and then I can get my answer that way. So that's what we're going to do here. It says the price of an item. So we don't know what the price of that item is, so I'm just going to leave that as P. Okay, that's the price of the item. Plus, so I'm going to do plus 6% sales tax. So I'm going to convert this 6% to a decimal, which is 0.06. But it's not just plus 6 cents, it's 6% of that item. So I have to do 0.06 P so that I have this together. So this would be the price of the item plus 6% of that item, and I would get the total, right? And I think on your homework, they're going to have you write this two different ways. They're going to have you write it as the left side, this expression over here, okay? But that's also the same as, think about it this way, if I put a 1 here, it would be 1p plus 0.06p. If I combine those, because they're like terms, I'd get 1.06p. All right, so that's two separate ways to write it, and I think they're going to have you do it both ways on your homework. Let's check out the next one here. Okay, the next one says 25% off of an item. Okay, so now we have this item again. I'm going to call it P, and now we're going to do 25% off of that item. So I have 0.25p, except we're subtracting here because it's 25% off. So I'm going to take that away from the original price. Okay, so this is one way to write it here. That's one expression. And then again, if I rewrite this as just one term when I combine like terms, 1p minus 0.25p would give me 0.75p. So two separate ways to write that. And then we'll go down to the last one here. It says the price of a car with 8.5% sales tax. So I'm going to say C is the price of my car with, so I'm going to tack that on. So that's going to be plus 0.85% sales tax. So that's going to be 0.085. Notice I'm converting that percentage to a decimal. And it's not just plus 8 cents, right? It's 8% of the car, so I have to do times C. And then again, if I want, I could rewrite that as one term. This would be 1C plus 0.085C is 1.085C. So two separate ways to write that. All right, we'll keep going here. Okay, we're going to do creating and solving equations here. These are some words that you may see that will indicate which symbol you're going to use. So addition would be things like sum. All right, we've got sum and added to, increased by, right? Those would be things that would be addition. Subtraction, we know would be less than. That's a good one, right? Minus, the difference, that's a good one. Okay, multiplication, times, obviously multiplied. Product is one that you've heard before. Division, okay, divided by. Quotient is a big one, right, for divisions. These are just some words that will tell you which symbol we're going to use. And then one that I want to add that they don't have in this table is when we see is, the word is, oftentimes that's going to be equals. Okay, so oftentimes the word is going to convert into an equal symbol. So let's take a look at the first one here. It says 10 times the sum of a number and 6 is 140. So first I'm going to look at this, the sum of a number and 6. So I don't know that number, so I'm going to call it n plus 6, because that's the sum of a number and 6. But it's not just n plus 6, right? It's 10 times that. So I'm going to multiply this whole thing by 10. And then it tells me is, that's my equal sign, 140. We look at the next one here. It says Aaron and Sam are bowling. Okay, so we've got Aaron and Sam. It says Sam's score is, so I've got S equals, right? Sam's score is twice, so I've got twice, so that's going to be multiplying by 2, the difference of Aaron's score and 5. So Aaron's score, and since it's difference, I know that's subtraction, and 5. It says the sum of their scores is 320. So if I put Aaron's score with Sam's score, I put those together, I should get 320. So I'm going to set up another equation. Aaron's score plus Sam's score equals 320. And then we can go ahead and use some substitution, which we're going to get into a little bit more in depth in later lessons. But right now, notice I know that S over here, right? S equals this piece. So what I'm going to do is I'm going to substitute in this whole thing where S is, because that's what S equals to. So we end up with this. I'm going to drop down the A plus, instead of S, well, I know S equals 2A minus 5 equals 320. And then I can go ahead and solve this. Distribute the 2, so I get A plus 2A minus 10 equals 320. Continue solving here. A plus 2A is 3A. I'm going to add 10 to the other side, equals 330. And then divide both sides by 3, and I'm going to end up with A equals 110. Okay, and now I need to know what S is, so I can plug it into either one of these equations. I can plug in A up here, right, or I can plug in A over here and solve for what S is, right? And we know that the combined score has got to be 320, so that means that S must be equal to 210. All right, we keep moving here. It says a rectangular garden is fenced in on all sides with 256 feet of fencing. The garden is 8 feet longer than it is wide. Find the length and the width. Okay, so we've got this garden that's a rectangle. Okay, and it tells me that the whole thing is 256 feet. The perimeter is 256 feet. So we've got 256. I'm just going to put that in the middle so I don't forget it. It says the garden is 8 feet longer than it is wide. So if I'm going to call this the width on the side there, then this bottom piece must be the length, and it tells me that that length is actually W, but it's 8 feet longer than that, right? It's 8 feet longer than the width. So I'm going to do W plus 8, because I know that it's 8 feet longer than the width. And so then, since it's a rectangle, I can go ahead and write W plus 8 at the top, because I know that each side is congruent, right? Opposite sides are congruent there. And then over here. And now we can go ahead and combine all of our pieces here. So I'm going to set up an equation. It's going to look like this. We've got 1, 2, 3, 4 W's. Right, we've got 4 W's, so that's going to be 4W plus, well, we've got 8 and 8, so that should be plus 16 equals 256. And then we can go ahead and solve it. So I'll subtract 16. I get 4W equals 240. Divide both sides by 4, and I get W equals 60. Okay, and then remember the length is 8 feet longer than that. So I'm going to say L must be 68. And we end up with our answers. All right, moving on to the next page. Okay, it says Jan has job offers at 2 companies. One company offers a starting salary of $28,000 with a $3,000 raise every year. The other offers a starting salary of $36,000 with a $2,000 raise every year. In how many years will Jan's salary be the same? Okay, so that's the big part here. Be the same, right? When we see that, that's going to be the equal sign, right? Because we want 2 things to be the same. We want them to be equal. So I'm going to set up 2 different expressions. One for company 1, right? The first company. And for that company, we have $28,000. plus $3,000 every year. So plus 3,000. But it's not just one time, it's per year. So I'm going to do 3,000y because that's going to increase every year. And we want to know when that's going to be the same as her other company, which offers 36,000 plus 2,000 every year. Okay. And so we end up with this equation here, right? And now I need to get y by itself. So what I'm going to do is I'm going to subtract 2,000y from over here. Subtract it to both sides. Okay. And I'm also going to move this 28,000 to the other side. So subtract 28,000 here. All right. And then that's going to give me 1,000 y equals 36,000 minus 28,000 is going to leave me with 8,000. And then divide both sides by 1,000, and I end up with y equals 8. So that's going to be in 8 years. It says how much money will she be making when they reach the same salary. Okay, well, if I want to figure out the amount of money she's making, I can take this 8 and plug it in for y into either one of these expressions, either on the right or on the left there. Okay, and I can figure that out. So I'll go ahead and do that. I'm going to do 28,000 plus 3,000, but in the 8th year. So I'm going to plug in 8 for y. That's going to be 28,000 plus 24,000, which is going to give me a grand total of 52,000. So the big part there is when it says be the same, right? We're setting these two expressions equal to each other. That's what's going to happen in the next one down here below, the last one. It says Claire bought just enough fencing to enclose the rectangular garden or the triangular garden as shown. The two gardens have the same perimeter, so we know that the perimeters are equal. How many feet of fencing did she buy? So if I look over here at the triangle, if I want to figure out the perimeter here, it's got 2, 4, 6 x's. And then we've got a -1, right? -1 and -1, so that would be -3. And then on the right side, we've got this rectangle. And again, since opposite sides are congruent, I'm going to put 3x minus 3 and x minus 3. And now I'm going to go ahead and add up my x's. Well, let's see. I've got 3, 6, 7, 8 x's. And then let's see, I've got -3, -6, -9, -12, so -12. And I'm trying to figure out when these are going to be the same. So then I can go ahead and solve this equation here. And I can subtract 6x from both sides. And I get -3 equals 2x minus 12. Add 12 the other direction. I get 2x equals 9. Divide by 2, so x equals 4.5. And then it wants to know how many feet of fencing she bought, so I can go ahead and plug that 4.5 into either one of these expressions, right, into one side, and that should be the same for both of them. So I'll go ahead and plug it in for the triangle. So that would be 6 times 4.5 minus 3. And so then I can evaluate that. Let's see, 6 times 4.5 is going to be 24, 27 minus 3. And then I can finish that off. That's just going to give me an even 24. And that's going to be feet. Okay, thanks for watching.